peer-reviewed publications and is currently president of the International Society of Biometeorology. He earned his bachelor's and his master's in meteorology from Rutgers and Texas A&M respectively, then came to Delaware to get a PhD in climatology in 2000, with his work on the redevelopment of an air mass classification scheme for North America with applications to climate trends and teleconnections. And I think it was Drs. Cockstein, Green, Leathers, Mather, and Schunemeyer were on your
Yes,
committee?
yes.
Okay. Today, Dr. Sheridan is going to speak on climate and human health. And with that, I very much welcome you to Delaware.
Thank you. All right. Thank you for the warm welcome and good to be back, even if virtually. So I thought before I started, I do want to talk a little bit about how I got into what I'll be presenting to you about today. So as you heard, my dissertation was on a weather type or air mass classification scheme, and I work with Dr. Larry Kalkstein on that. And that's something that has been relatively, significantly connected to a lot of my research agenda. A lot of my papers and such were based on that. But in part, in working with Dr. Kalkstein on my PhD way back when, a lot of his interests were on synoptic climatology and human health outcomes. And so one of the areas I got a lot of experience outside of my dissertation work was on looking at climate and human health. And so in terms of my research trajectories, since I left Delaware and came to Kent State, they kind of went in two different directions. One was on the climate parts themselves, on synoptic climatology. I've continued to work in that area. In a lot of extensions of the work that I did way back when I was at Delaware, but then also continuing on in climate and human health work. And some of that is related to synoptic climatology. Some of it is just general climatology overall. So, when you hear my dissertation title and you hear what I'm talking about today, they really are very related. It was just an arc that I got through my experience as a PhD student while I was at Delaware, from working with my advisor on material that was related to what I was doing, but wasn't directly in my dissertation. So what I'm going to present to you today, and I will share my screen again, and if it is a little wonky, please do let me know. Hold on. Okay, is it back to full screen now?
There you go.
Okay, perfect. Okay. So what I'll be presenting to you now, you can see the title, Climate and Human Health, New Directions, is an overview on where climate and health research has gone over the last half decade or so. And so I'm taking a little bit different of a tack than I do with some other colloquia that I've given, in that I'm not going to be showcasing just one project that I'm doing. In fact, I'm not even going to be showcasing only my work. I'm really going to be talking about the broader sphere of climate and human health. And then I'll be bringing in some of the research that I've done and that I've been part of as we get towards the end of it. And so I want to really kind of present this holistically to give you an idea of where we've seen things develop in recent years. And so the one graphic I start out with in a lot of my classes, to me, helps exemplify why looking at climate and health in many areas is something that really fits very well in the discipline of geography. I will always, try to tout geography and what geographers do as much as I can. But if you look at the general ways in which we connect, vulnerability to extreme temperatures, we have heat on one side. This is just one example, and as you can see from the date, this is a fairly old concept diagram. And then you have a negative health outcome on the other. And so we know that extreme heat on the left side can tell us, we learn a lot about that from understanding climatology, climate variability. Factors affecting exposure is something that can really connect us with microclimate, or also what people are doing in terms of whether they're outdoors or indoors, in terms of whether they're working. And so you really bring physical geography into that. You can then look at factors affecting sensitivity to given heat exposure. So this can mean differences as we age, differences due to health conditions or what medications we're on, and so on. And so here we get into the biometeorology part, which is how our bodies respond to the weather, and how varied that can be from person to person. And then lastly, you have factors affecting the access to treatment, and this can get into socioeconomic categories. Whether someone is a linguistic minority and may not be able to, it doesn't hear heat warnings or other things as readily as others do. And so you really get into the socioeconomic aspects as well. And so when you connect all of these, what I do like, and where again, to talk about where I see geography fitting in very well, is you have components of the physical, the biophysical, the socioeconomic. All of these we can really connect in with a lot of the geographic principles that we look at, both on the physical side and the human side. And so I really like starting out with that when I give talks, because I think it's really a very good way to kind of shape everything that we know about climate and health. So I apologize if this looks a little bit small to you, but this was one of the most interesting graphics that I saw very recently, and I think this talks pretty well to what it's like trying to do a literature review today in any area. So one of the things I can speak to from doing my literature review back as a grad student ages and ages ago, was having to go to the library, having index cards for each journal to try to remember which was the last issue I looked at. And I thought that was frustrating. But now in the modern day era, with the rise in the number of publishers, the rise in the different number of venues, I'm sure you can all relate to the fact that it gets very hard to try to find what is most appropriate literature-wise. And this paper, it's now 4 years old, so I would anticipate that these numbers have only grown. Used an earlier form of artificial intelligence with the entire corpus of abstracts from peer-reviewed articles in the English language, and estimated that between 2013 and 2020, there were over 15,000 papers published on climate and human health, broadly speaking. And so that's something that, as I'm sure you can imagine with that number, is basically next to impossible to try to analyze all of that yourself. And so what was done was analysis on common themes within the literature, both in terms of the meteorology, the impacts, and so on. And so what we can see on this chart is, if you look at the gray, you can see that there's a fair amount on the climate hazards themselves. And of course, climate change ends up being the most substantive. If you look at the blue on the bottom, you have a lot on public health and air pollution, but then you really go down into a very large array of different health outcomes. Some of them we've studied for decades and decades, like infectious diseases, especially malaria, trying to understand how climate can affect that. But you can also see, and I'll talk about this a bit more here in a moment, how this connects to things like mental health and a lot of other outcomes that were not as readily understood a long time, decades ago. We can then go into, looking at mediating pathways, and then options, and responses. And I want you to notice that once you start getting into responses here, in terms of the orange, you start to see much smaller bars. And that's one thing that I'm going to be coming back to as we go through the rest of my talk is that you see there's a lot of studies on climate and health, but connecting it in with how that can help us inform policy, how that can help us improve health outcomes is something that really hasn't been developed as much as it could have, and I think we need to look at moving forward. So broadly speaking, I talked about some of these already. So if you go back when I was a graduate student, way back when, and I gave you a broad recurring themes in literature in whatever form of PowerPoint was available way back then. It probably would have looked something just like this. These themes in and of themselves really aren't that new. There's been a lot of studies on meteorological extremes, on air pollution, as I mentioned, vector-borne diseases and as well as other infectious diseases. And so from the climate health perspective, there's a lot here that we've seen for quite a while. But what's interesting about this is that one of the things that, as geographers, we all know is that the world is not equally well studied. And so if you look at the graphic that I'm showing you here, this looks better than I would argue that any graphic would have looked like a couple decades ago when it was very heavily concentrated on North America, Western Europe, and then Eastern Asia. But you can still see that there's a big dearth of climate and health studies in many parts of the world, particularly the more developing areas of the world, even to this day. The other thing that we can also see, and again, this might be a little small for you depending upon the screen you're looking at, is that the particular topics vary from place to place across the world. So if you're looking at North America, you do see a lot of impacts of extreme conditions like hurricanes. You also see a lot of studies on particulate matter. If you look at Europe, they have a lot of studies on heat waves, something that they've been really prone to, especially in the last 15 or so years. Um, Whereas if you look at Africa, a lot of the studies on climate and health tend to be focused on rainfall cycles and droughts and floods. And so the areas that are studied and the themes that are covered really do vary quite a bit. And the same goes for the health impacts and then also the responses that are promoted in each of these articles. So now I want to turn a little bit to looking at some of the more emerging themes in the literature. And so one of the common themes that I'll talk about throughout a lot of the slides that I'll be showing you here today is in terms of increased availability of data. So one thing that I've seen through my career, and I'm sure all of you can appreciate, is that we currently have access to far more data now than we did a while ago. Data are much more easily accessible, and there's a lot more ways to robustly statistically analyze it. And so, in comparison to the way things were traditionally, there's a lot more available for us to actually research, which makes for some really fascinating research topics. One of the examples I'll give you is occupational health. And so if you look at the first graphic on the left-hand side, these are statistics on the number of deaths of migrant workers in Qatar with the monthly wet bulb globe temperature maximum value. If you're not familiar with that, don't worry about it, but basically you just go hotter as you go towards the right. And so what you see with this in particular, I'm sure many of you know, but if you're not in many of the Gulf states, you have very specific recording of immigrant labor versus domestic labor. And immigrants, especially male workers, tend to work very heavily in outdoor industries. And so you end up with a very large, robust database on migrant workers that work occupationally outdoors. And so a lot of this grabbed significant media attention leading up to the World Cup 4 years ago in terms of stadium construction and a lot of the lives that were lost in that process. But we can actually see fairly significant impacts on occupational health in migrant worker deaths that really don't show up in any other subset of the population if you're looking at Qatar. Pregnancy outcomes are becoming a lot more readily studied. There's a lot of longitudinal studies that look at maternal health during pregnancy, excuse me, and soon thereafter, with databases that record environmental conditions, residences, and things of that sort. And so, one of the big outcomes we can see is that if there is late-term heat waves, excuse me, late-term pregnancy-wise heat waves, it tends to raise the increase of preterm birth, and also tends to reduce birth weight, and there's a number of other potential negative health outcomes there. And so with the availability of additional data and cohorts that are participating in studies, we can then tie these factors in. We can also look at mental health outcomes. There's a very significant increase in studies in looking at impacts not just on suicides, but also mental health outcomes for hospitalizations, clinic visits, and so on. And we could see ample evidence in many areas of the world of negative health outcomes of all sorts increasing when you have extreme hot weather. And so one of the things which is really interesting, and again, this kind of comes back to the geographic lens, is looking at how climate affects human health through all the different pathways. And so one of the themes that's been around for a while in the climate and health literature, but actually has really come more to the forefront as climate change has affected more areas worldwide, is on farmer mental health, especially within drought. And there's a large literature database in the US, but it's even bigger in places like India and Australia, where you can have very profound impacts from year to year. And so what you see is you have the climatology or the climate impacts, but then you also have you have business impacts, you have socioeconomic impacts, a lot of other factors, healthcare access impacts that collectively impact well-being. And the spatial variability in those, I think, has led to a lot of geographers looking at research within this space to see how you can take just an extreme weather event and connect it in with a negative health outcome and look at all of these mitigating factors. Climate change is something that we also see at the forefront of studies. And so we know that climate change has been studied for a very substantial time. And starting at around 10, 15 or so years ago, we started to look at climate change attribution, and then the way that's usually framed is when the context of if you had an extreme heat event or if you had an extreme flooding event or drought or something of that nature, um, how much more likely was that due to anthropogenic climate change? And then starting in the last 5 or so years, there have been attempts to try to look at that with human health outcomes as well. And so what we see is an increasing number of studies that have looked at not just how climate affects health, but how the changes in climate have further caused deterioration in health as well. And so you can see that if you look at the graphics, both of these, you can see an increase in heat-related mortality overall globally. And I'll come back to contextualizing global impacts versus that in the United States here a little bit later. And you can see it very heavily concentrated in some of the areas in Europe, and then other areas in Latin America that have seen substantive increase in extreme heat conditions over the past couple of decades. And so I do want to stress that, well, this is something that we haven't seen as much research done historically, but with a lot of the research that's done with regard to climate and health, how changes in climate affect health is a new direction that we're building on. And then one other area which I always have debated whether or not I want to talk about or not because it's complicated is that of COVID and health and climate. And so working as a journal editor over uh, through the COVID era was really interesting. And it was the first emerging disease that I think captured people's interests very substantially in real time. I'm sure all of you remember all the databases that we had access to, all the statistics we heard day in, day out. And of course, there was a very large amount of time that people had during the lockdown and soon thereafter. That meant that there were a lot of research studies that could try to look at the role of climate and weather variability on the transmission and outcomes from COVID. And so if you look back in the literature, go back, you'll uncover this whole plethora of different discoveries. And a lot of that reflects, to me, fascinatingly, the scientific process where you start with the data you have and then you gradually, get more data and see how all of this stuff fits in together. Ultimately, though, what the research comes out to show is that, unsurprisingly, the vast majority of COVID transmission had to do with dynamics that go way beyond the weather. That is, when you had new, very transmissible strains of COVID, you actually ended up having much greater transmission regardless of the weather. So there is some connection between temperature as well as absolute humidity and COVID. So if you're indoors more because it's colder out, and also if you're indoors in drier air, which is what the absolute humidity factor is getting at, COVID tends to be transmitted more regularly. But when you have the larger way in which COVID unfolded, that tended to overwhelm the signals, for the most part. Now that COVID has subsided a bit more into a seasonal disease, similar to influenza, we're starting to see kind of the more regular season cycles that you see with influenza over time. The other really interesting area of research that uh, climate scientists, biometeorologists are really starting to explore is new technology. And the new technology really gets at a number of different things. There's a lot more interest in understanding different things you can get from satellite and other optical sensors. But I think the fascinating thing for me most is on citizen science, including the use of wearable technologies. And this affects everything, including some things that you probably are already doing. If you have an Oura Ring or your iPhone is giving you health information about yourself, you are a data source. And so if you look at this and how it's aggregated over larger groups and you connect it in with um, meteorological impacts, you can see how climate affects us physically on a very direct level. And so there's been a lot of studies that look at kind of aggregates of sleep records to see how well people sleep, to look at other factors like stress. But what to me I find most interesting is how a lot of these new wearables really tend to turn on its head our understanding of climate and health relationships when you realize how everything is very individualized. And so my point here is well exemplified in the graphic on the right-hand side, where what you see are different sources, or excuse me, two different seasons, warm season on top, cold season on bottom, and then daily pollution outcomes or exposures, excuse me, for three places in China. The one on the left-hand side is urban, the other two are rural. And each line here represents a different space. And then the purple line represents the experience of the person moving through space. And so what you see is, we've long understood that your personal exposure may vary from place to place. But what ends up happening is you can see that in many cases, especially in um, areas that use more traditional cooking methods, is that the kitchen is actually the worst place for particulate matter exposure, especially based on ventilation. And so what we actually see is that the pollution exposure in many areas really has very little correlation with outdoor weather conditions. And so when we traditionally would look, and you could look at studies going back decades that look at area-wide air quality. So you hear that it's a bad air quality day for all of Newcastle County, but realize that individual exposures are going to vary tremendously from one place to the next. And what you can see on the graphics here is that the individual exposures in this case were actually much worse in rural areas than urban areas, and this largely reflected differences of cooking mechanisms. And also the length of time people spent in the kitchen. And so what I like with this is that a lot of the new technology is kind of throwing older studies, epidemiology studies on their head, where we look at larger scale aggregates to realize that individual exposures, especially with regard to air pollution or extreme heat, can also vary very tremendously from person to person. And that's really interesting and something we can really only gain a handle of through a lot of the new technologies that we have today. So one other theme that I'll talk about that comes up a lot, and you do hear a lot of this politically in the political realm, is in terms of how climate shifts and then other environmental factors affect migration. And so this we lump together in something we tend to call climate migration or climate migrants. And so there's a lot of interesting studies that have taken place. There's obviously short-term disasters where, you can think of, say, a Hurricane Katrina, where you have a meteorological disaster which has a very substantive negative impact on an area that displaces a large number of people, and then you eventually have a response to that. Versus long-term migration, which is what you see um, ascribed to a lot of the migration that you see in many parts of sub-Saharan Africa with regard to long-term drought and also the tenuousness of crops. There's a lot of other studies that look at perception versus reality. We tend to have a really bad recall bias when it comes to weather. We tend to remember only the worst and how something ended. And so if you had a winter that had one really bad blizzard and then ended on a really cold note, psychologically we tend to remember that as being harsher than if things happened slightly differently, but it still came out to the same overall average of conditions. And then there's also a lot of other components such as politics that play a role. And if you look at a lot of our discourse now on migration, you could see a lot of this being very relevant to that debate too. In terms of technology, one thing which I thought was really interesting was looking at migration to and from Puerto Rico after Hurricane Maria. And this used tweets of people that were had their home address coded as being in Puerto Rico. And so what you can see is the displaced people in the first couple months, so the blue lines. And then you can see the red lines or orange lines represent people whose tweets ended up returning to being typed in Puerto Rico. And so you can see that after 9 months, roughly around 60% of the people that were displaced by Hurricane Maria had returned to Puerto Rico, meaning 40% hadn't. And a lot of this data is really hard to get. If you look at the way we look at migration, especially with the natural hazards, it's really hard to try to get a good sense of what's happening. But here at technology, this actually did give us some really interesting data sources. One of the things about climate suitability that we see ends up being with regards to what may happen in the coming decades. So a lot of this does get caught up in a lot of the climate policy discussions that we have. And so there are a myriad of studies that are starting to look at the potential suitability of places for agriculture, for water availability, as well as marine species, and so on, and how this can affect climate migration in the future. If you follow the news, you would recently from Iran, you would see that the Iranian government is contemplating moving their capital city from Tehran to the coast, largely because they can't guarantee that the water resources are going to be sufficient for that population, that size population moving forward. And so this is one case where you can see directly the potential for a large-scale migration through shifting of a capital city, and this wouldn't be the first, in order to accommodate for environmental changes. The last few summers have brought about a number of headlines of what are our physical limits of tolerance. And so what does that mean? Well, our human body, we have several different ways in which we try to dissipate heat. You can radiate it out through your body. And then you also have convection, which is our outward breath. And then we have sweat, which is our evaporative coolant as primary mechanisms. Um, we do this to respond to our body overheating, but you can eventually get into conditions that are so hot and or humid that the body can no longer compensate. In other words, all the mechanisms that our body can do to offset the heat are not enough to keep us from running constant thermal surpluses, meaning that our body just keeps getting warmer and warmer. And so there are theoretical studies that have tried to account for what our theoretical limits are. But there's also been a very substantial number of new laboratory studies that try to understand what this is like with actual people instead of just theoretical human physiological responses. And so what you see is that there are lines being drawn to try to help us understand what's unconceptible, meaning our body cannot thermoregulate sufficiently in terms of extreme meteorological conditions. The graphic I'm showing you here was just with young college students, all in relatively healthy shape. And newer studies are starting to look at what about older people? What about people acclimatized to different areas? And so there's a lot of different areas in which we can look at what our thermal tolerance limits are and how that changes based on us, based on our acclimatization and so on. as we move into the future, one of the big issues we're going to be dealing with is changes in demography. And again, this kind of comes back to a lot of the interesting geographic work that's been done. So if you're not as familiar with the acronyms that you see all scattered down the left-hand side, don't worry about that. Those are basically just climate change scenarios of different socioeconomic pathways and different climate greenhouse gas pathways. What I want you to look at, though, are the colors of the bars, and these are for five of the largest sub-Saharan African cities. If you look at the impact of climate change going into the future, the green component of the bars, you notice that there's not a huge contribution, but rather what you see is a very substantive contribution of population changes. So these urban areas that are very, very rapidly growing presently, and then also the interaction between increased urban heat island because of a greater urban population, also anthropogenic climate change, and all of this together then very rapidly impacts human health or human vulnerability in a negative way. And so as we look forward, you're looking into the decades ahead, I imagine that there's going to be a much larger amount of vulnerability we see in rapidly developing urban areas. Some of it's going to be climate change related, but a lot of it is going to be related to urban heat island and population change and the combination thereof. So in terms of our broad environmental impacts, there's been um, two main themes that we've seen historically in the literature. And that is that areas that have a stronger urban heat island tend to have a greater risk of heat-related mortality. So the right box pointing to the top box. And then there's a lot of socioeconomic categories that are connected in with greater heat-related mortality. And that's the left box, the top box. But research over the past several years has started to connect in how these two lower boxes are directly connected to each other. So those in certain socioeconomic categories and those, or excuse me, socioeconomic and also physical categories, such as those that are older, tend to be located in areas that have a stronger urban heat island. And this came out very popularly in the popular literature starting in the summer of 2020, looking at studies of former redlined areas. And so if you're not as familiar with this, going back decades, there were areas that were identified as being preferred for housing for mortgages and those that were less preferred. And what ended up happening as a result was that you tended to have a much greater segregation of populations based on these redlined areas. And what's interesting that you can see here is that these areas have heavily evolved since that time, even in absence of this policy, because the urban geographies are different. There's much denser housing in areas that were deemed to be of lower appeal. There's much less urban vegetation as a result, still several decades later. And so even in a lot of these former areas, several decades after any of this policy officially ended, we still see very significant disparities in areas in major US cities. You can also see this elsewhere in the world. A study from last year on Brazil looked at race-based differences in heat-related mortality through the largest cities in Brazil. And you can see a very substantial impact in most cities with very substantive, statistically significant differences between the white and the non-white populations for all groups that were assessed. And so a lot of this has led to trying to understand how do we actually work on mitigating some of these issues. And so there's a lot of research in terms of looking at green space and urban form, and what this means for human health. There's a very large, robust literature looking at mental health benefits of additional green space. I won't be talking about that, but one of the side benefits, of course, is that when you have much larger green space, you tend to have lower heat islands. And so one project that I worked on was to look at Los Angeles with some urban modeling, to look at what the difference in urban climate would be in historical heat waves based on the amount of vegetation and urban design changes, so white roofs that existed throughout different areas. And so if you look at the graphic on the lower right-hand side, baseline refers to the existing number of ER visits in Los Angeles County for those four historical heat events. And then you could see with the simulations and changes with low, medium, or high amounts of additional greening, you can see that you have drop-offs simulated of ER visits on the order of as high as 25 to 63%. So in other words, by engineering the urban climate to reduce the urban heat island, their possibility of reducing heat vulnerability can be pretty substantial. Of course, this is not a cheap proposition, and this is a much longer term proposition, but nevertheless, this is something that is being studied. So with all of this, uh, the other thread that's happened is in the last several years, we've just seen these phenomenal headlines. And I think the one that I remember most, I guess, in my rotations of some of these headlines, I've lost it. But if you look at 2021, where you had Portland and Seattle reach 116 and 108 degrees respectively, which were not only all-time records, but just completely obliterated any experience of heat that had happened before. If you look at last summer, which is the graphic on the upper left behind the header, Miami just had 175 hours above a heat index of 105 degrees. And if you look at what had happened in the years before, it was entirely, just not only exceeded it, but just obliterated the records. The same can be said for a lot of the other records that are happening. And so one of the things that we are also looking at with heat research and climate change is what happens when you have these unprecedented events. We look at the way we normally study climate and health. It's through a lot of statistics, through regression models. Everything is based on this is the range of what can happen. This is the range of what the response is. But what happens when you start to get events that are just entirely beyond that realm? Extreme heat persisting as long as what you see in Miami. Or last year in Tokyo, was the first time that high temperatures were above 30 degrees C every single day in August. And Japan has had phenomenal amounts of records for heat over the last 3 summers, back to back to back. What happens in these situations? So now that I've set the stage, a couple of different things where I want to draw a little bit more on what I've done to kind of help contextualize some of a lot of what I've talked about. So if you look at overall trends in heat vulnerability within the United States, you will see that there is, generally speaking, over the last several decades, a downward shift in overall response. Now, I want to put a little bit of context on this. And so I'll focus first on the lower right-hand box that you see there where it says national. On the y-axis, you have the relative risks. And so where you see it go as high as 1.4, that means that on an excessively hot day, you don't have to worry about how that's defined right now. the mortality rate, the likelihood of mortality would be roughly 40% higher than it would on a day without the excessive heat. And so if you look back to the 1970s, which is the left-hand side of that box, you could see that heat days had roughly around an 18 to 20% increased likelihood of mortality way back in the 70s and 80s. And by now, in 2010 to 2018, the most recent era, that's fallen down to around 3 to 5%. So the overall relative risk of heat mortality through heat waves nationally in the US has dropped. Why? Greater awareness, much more air conditioning, better healthcare coverage overall from the 1970s to today, newer housing stock that has, that is much better built to accommodate extreme heat, and a lot of other factors that play a role. What I want you to see, though, is that if you look at across the country, you notice some different themes, which is that in the Northeast and Midwest, you actually see the greatest drop kind of more steadily over the course of time. If you look at the Southeast, in many areas of the Southeast, you had a really deadly summer of 1980, one of the hottest summers on record, which was really one of the biggest catalysts for really ramping up air conditioning use in many areas of the South if it didn't exist already. And so you notice this big drop starting in the early 80s. In other areas like the Pacific coast, you see much more variability over time. And these include a lot of cities such as Seattle and Portland and San Francisco that don't have a lot of housing stock that has central air conditioning. The heat wave of 2021 that I talked about a few minutes ago is really starting to change that in those areas because the reality is clearly different than it had been. And so it's interesting to me is that if you look at graphics like this, you see that stories of the different geographies across the United States, not only in terms of climate variability, but in terms of housing type, in terms of air conditioning prevalence, really can vary quite a bit in terms of the overall trajectory of heat vulnerability. Now, while this looks better in terms of the overall response, one counteracting thing is even if we're less vulnerable on any given hot day, as you can see on the lower left of this chart, there's more hot days. So even though you're less vulnerable, it's still hotter for longer, which offsets some of those gains. There's also interesting demographic differences. And so this is the percentage of all deaths associated with the heat. This is something in public health or epidemiology literature we call the attributable fraction. So the percentages of deaths or hospitalizations that you can attribute to something. And if you look at the overall trends, you can see that those are generally downward. But the one thing that is different is if you look in the lower right-hand side, you see that for men aged 45 to 64, there is no downward trend in heat-related mortality at all. And so I want to, process that. If you look at these 5 charts, you can see a clear downward trend in 4 of the 5, but not the 5th. And so there's a lot of interesting theories behind a lot of this. One, the death rate for those 45 to 64 is less than those that are older, but still it hasn't changed over time. A lot of the later years, we're theorizing may have to do with changes in overall health conditions. We know that life expectancy in the U.S. Hasn't kept pace with many other areas. We've seen a much larger increase in mortality of middle-aged folks, particularly men, due to the opioid epidemic, and a lot of other related healthcare crises over the last decade. And so it's interesting is that the heat exposure, heat-related mortality really hasn't gone down as a result. And so there's been this study that I worked on ended with data in 2018. You can see it's now a few years old. There's been some additional studies that have looked at this as well, but it's really hard to disentangle what might be any driving factor. But I do want to point out here that you do see, again, the overall trend may be downward, but the different subpopulations are not all equally affected. So I've spent almost all of my time talking about heat. And the last couple slides, I want to kind of bring in other potential factors. And one is that historically, we've focused on heat because that tends to have a much more acute impact. We've all seen headlines, heat wave kills blank, sends this many people to the hospital. We can see the direct impacts. If you look throughout many areas in the temperate parts of the world, roughly 15% more people die in winter than summer. And that's largely because you have much greater transmission of respiratory diseases during that time. And then there's a lot of other impacts of extreme cold that I won't talk about here today. But what's interesting is that if we look at this, generally we see the overall toll of cold can be greater than it is for heat. It's very difficult to deal with extreme of cold because the cold that tends to lead to increased mortality just tends to be winter overall. And so if you're in a place like, I am here, you are there, even within a climate change context, winter does not just entirely go away where suddenly you don't have to be indoors for much of the year. And so the conditions are a little bit harder to ameliorate. But what we can see is if we look at the relative comparisons, you can see where over the course of time, in many very um, temperate to almost boreal areas, this is Stockholm that you can see here, the impacts of heat are becoming so much more in recent decades and moving into the future that heat may actually become worse of a problem for Sweden than the cold is by the time you get towards the end of the century. Which, if you think about the general climate of Sweden, is really quite something. Another thing that we have to talk about is our general reliance on technology. And so this, I've worked on a number of projects with New York State in terms of looking at health impacts from extreme events and other data. And so there is a ample database on power outages for New York State that's maintained. And so we had a really interesting data set we were able to compile on extreme wind events and power outages. And what you see is wind events tend to lead to a bit of an increase in mortality, power outages slightly. But when you have power outages during wind events, you create much more hazardous conditions where people have to go out. You may have downed power lines. You may not have access to all the technologies that you're used to having, and that creates a much, much larger hazard. You can see this also with extreme events. After Hurricane Irma happened, there was a lot of focus on Irma's direct impacts, but the recovery, where many places didn't have adequate air conditioning because the power grid was still out, you ended up seeing death tolls that were associated with heat-related mortality because of air conditioning loss. Uh, Same thing for winter storms. This is my old dog trying to help me dig out of the snow. The last time I lost power, where you have a very substantial winter storm, which can create very large traffic hazards. But then if you also have a power outage, what happens? People don't have central heating. They may be under stress. They may have to try to drive somewhere, which then puts them at further vulnerability because of ambient weather conditions, which then tends to lead to greater vulnerability. And so the reason I bring up these last two slides is because we tend to talk a lot about how to deal with extreme weather events, but one of the biggest ways in which we do that is looking at technology, increased air conditioning, number one, when it comes to heat. Well, that's very reliant on the power grid. And California each summer, especially, has huge strains on their power grid whenever they have extreme heat. And so relying on that as a way of dealing with extreme weather conditions is really tenuous when the power grid gets strained when you need it the most. So I'm going to close now with just a couple observations. And so this is a kind of a word cloud of sorts, or a cluster of the same papers that I described to you way back at the start, some subset of the 15,000 papers. And so if you look at the overall themes, these are aggregated by what you see the papers aligning with. I'm not going to talk about all the stuff that's on there. There's a lot of interesting stuff. If you're interested in the paper, you can see the DOI there. It's really fascinating read. But what you see is in the little inset box on the right, which is that impacts of climate on health is really well studied. Mitigating those impacts is less well studied, and adapting it is even less well studied. And so this is the challenge that I think we have as geographers, which is to bridge the gap between the physical environment, the physical climate, and the societal components. So not just socioeconomics, but also policy, everything that we've talked about today, to look at how this can help bring about a better future. And the other thing that I think I want to stress is that a lot of this has to be very place-based. You could see, just go back to that China study that I talked about a while ago on how air pollution exposure for an individual person will vary phenomenally in rural areas based on whether you're in the kitchen or not. And that's something that, no large scale climate adaptation plan is going to deal with, but this is more about a very small scale based on what it is that one person is actually doing, which may be very different than what happens to someone in the next room. And so I think with the advent of additional data and wearable technology, and the way we can analyze it today, there's still tons to be done in terms of how we directly impact policy and how geographers can really analyze a lot of this. So with that, I'll say thank you, and I'm happy to answer any questions.
Thank you very much. Anyone have any questions? And I've got the chat up if you want to type in the chat as well. I see Salim.
Yes, thank you, Scott. I think overall, the whole issue of climate and health is so vital, and actually, we're trying to have more of the coursework of covering this here at UD. My concern, however, is that some of this is kind of uh, driven by a certain predilection towards creating more alarm for people to act on climate mitigation. If you look at it from the point of view of adaptation, like, most of the large cities of the world right now, they would not be habitable without adaptive heating, whether it's Tokyo, the world's largest
Yeah.
city, or it's Beijing or New York or London or so on, Moscow, certainly. So when you hear headlines like, oh, Dubai is going to be uninhabitable, I find that also a bit problematic. So I'm wondering if you can comment on that. Plus, the energy footprint of heating is actually considerably more than cooling, especially if you do smart design around cooling,
Yeah.
or you have subterranean dwellings and so on. So I just do feel, much as I totally want to make sure we are well prepared, I find this, and this is coming from some of my work with the United Nations, and I'm wondering if you can comment on that.
That's a absolutely wonderful point, and I think, and I'm glad you mentioned it because it is something we're trying to give this overview. I I could see, I talked a lot about how climate can affect health, but there are health impacts. But there's also a lot of things that have nothing to do with the climate itself, or if you focus only on one impact, you may be at the detriment of others. And I think the comparison of heating versus cooling is probably one of the best aspects, especially with regard to building design. One of the things that we see, a lot of older cities is you have buildings, the same buildings that really struggle during heat events are really very well designed to protect and keep in heat during the winter time, which for most areas, in the stretching from where you all are to where I am, and everywhere northward, that's obviously a much longer window than the extreme heat in the summer. And so I do think there does have to be that nuance of what can happen and um, what may be detrimental if you do kind of write policy too broadly. I mean, I do think in one sense, what I do feel um, geographers can offer, though, is a lot more nuance to understanding these problems. And so one of the things, again, one of the things I didn't mention, but that a lot of the projects I've worked on with regard to heat and health is looking at who is the most vulnerable, so that rather than try to put out a broad message that really, kind of doesn't resonate with everyone, but look at what the most critical factors are that affect one's health. And so with that, you can get a much more nuanced place-based solution that isn't kind of broadly washing over an environmental issue and then potentially having some collateral negative impacts. So I do hear you on that, and I do think you have a great point on that. And that's something that often gets lost, especially when studies get turned into headlines. But I think that is something that needs to be accounted for too.
We have a very long comment in the chat with a
Sure.
question. Can you see it? Or I'm not sure.
Um, Maybe.
I can read it to you.
Okay.
It's long.
Okay. No, I got. Okay. Yeah. I think I. There we go. Got it.
Okay.
I know climate change, rather if they even notice you changes trend. Oh, okay, that's interesting. So that's a great question. So if you're in the room, see it. The question is about on how climate change impacts the lives of residents in Arizona, and how residents have adapted to handle climate change, and in terms of whether their observations are accurate or what their perceptions are in terms of the impacts. There's a lot of I don't know, no worries. There's a lot of studies. I mean, there's a lot you can look at with the social science literature on perceptions of vulnerability. And, in your case in particular, I think Arizona is kind of a very unique situation in that you have a lot of people that have migrated there over time. And so I think that the perceptions can be different based on the longevity of how long someone has been in the area. Um, and there is a fair amount of literature I know, especially with regard to farmers, in terms of looking at how their perceived changes in climate relate to observed changes in climate, which I think could be relatively interesting to look at. There are also a lot of other things that you can look at in terms of water availability. And I know, particularly in Arizona, you can look at drought frequency, but my take is if I lived there, a lot what you'd be hearing about is the Colorado River and then all the water resources that may be disappearing, the level of Lake Mead, and a lot of the other narratives that you see throughout the desert Southwest that are related to the droughts. But these are different conversations and something you would directly observe if you lived in an area, because a lot of the water resources are from precipitation that happens in areas that are separate from where you live. And so I do think one thing which would be interesting to see with what you're doing is in terms of looking at their own personal perceptions, but then they're also perceptions of the narratives of the hazards. Like what has happened over time? Or are people talking more about water running out, why, and so on, and then connecting that in with the research that you see on observed changes in water level and things of that sort. Largely because I imagine that someone living in metropolitan Phoenix may not really notice that things are all that much different water-wise because it's always dry there, and it's only through the narratives that you hear about the water resources affecting the broader area around the Colorado River Basin that you hear about the drought much more substantively. So I don't know if that is helpful, but that it's interesting. And I think the desert Southwest is probably unique in that regard for the U.S., where a lot of the biggest climate concerns are related to water that is falling several hundred miles away from where the majority of residents are.
You got a response that was very
Oh,
helpful. Thank you so much.
and I think, and I know also looking at the politics of sharing the water. I mean, yeah, I'm certain you absolutely know way more than I do about the sharing of the Colorado River resources, if this is what you're studying. And so how that gets discussed, how much gets devoted to agriculture, those are really fascinating questions without a very simple answer. But I think there's a lot of space there to look at more.
Scott, I have a question for you. I thought it was
Sure.
just just very interesting of the graph that you showed of the 5 cities in Africa where
Yeah.
climate change was not the driver. And in terms of those 5 cities, were they located in a similar type of climate? It's just kind of interesting that, it was more of what was going on with the land surface with things that climate change wasn't kind of the main factor.
Yeah, my take with it is a very good observation. My take on it, I mean, they were all generally tropical cities. I think Dar es Salaam is the least tropical of all the ones that was there. I don't have my slides up anymore, so
That's okay.
but I know where you have the climate shifts, the overall climate mean temperature climate change in those areas is not substantive compared to as much as it is elsewhere in the world if you look at the overall scenarios. But I do know if you look at the urban heat island metrics in a lot of these areas, those can be, an order of magnitude greater than the broader global climate change impacts. And so my take is that a lot of this is more indicative of the increased population and urbanization, especially where it's unplanned urbanization. So you tend to have, much greater urban heat island impacts than you would in other places that would then tend to make things much worse for people.
And I don't think I have any of the students that are in my advanced class, GIS class on anymore, but I took a snippet or two of a couple of your maps that you showed.
Oh,
The
yeah.
cartography was so wonderful, and it's interesting in terms of what you've been thinking about just, in the last few days that you have in your mind that a couple of those maps cartographically, the color rates
Okay.
were so beautiful.
Oh no, yeah, I can, and I'm happy to. I'll make a note. I
Oh,
can send you the PowerPoint, so this way
I
you.
Scott already snapped it with a reference to it to use it in the future,
Okay.
but I just wanted to comment on that. I think
Okay.
Amir, my teaching assistant, is on here, and Bakhtir has TA'd in the past. But I'm disappointed that a couple of my other students aren't on there. But anyway, just kind of fun because I'm just finishing up that class this semester. But thank you, Scott.
Okay.
It was a very interesting talk and just a really great message in terms of the place space is just so important when you look at all those graphs and how different the places can be in terms of the results that you're showing.
Thank you, Tracy. And I agree. I'm glad to hear your comments because I know with my students, I always stress that, especially when you're doing anything cartographically,
Oh,
how you set that
it's
up.
such a difference.
Yeah.
Yeah, because some of those maps and even the graphics in terms of things, some of them are just really, really, really great.
Well, thank you.
We have time for anybody else? A few more minutes. I would like to say one, thank you. I really enjoyed it because I have been interested in vector-borne diseases and how climate affects that. But on a different note, and I was really interested in seeing how the heat indexes had increased so much there was one of your slides, but
Oh,
that the
yeah.
death went down.
Mm-hmm.
And I'm wondering if that increasing in air conditioning could also potentially change how we look at vector-borne diseases because you don't have your windows open anymore.
Mm-hmm.
If there's a change in that as well, that would be kind of an interesting thing to ponder.
Yeah. I mean, I don't remember seeing much on, I mean, I totally see where you're coming from with that. I don't know if I've seen much on how, window or how closed off you are in your space has changed
Yeah,
over time to where that would impact vector-borne disease transmission. Um,
especially with, tree hole mosquitoes and stuff like that that are breeding in the gutters and around the
yeah.
houses. And it never had actually, I haven't done any active research for a while on this, but it just hadn't really occurred to me. And when I saw that, it was like, that's kind of an interesting thought.
Yeah. No, I mean, it makes sense. And I mean, I think with, well, I'm sure I mean, with a lot of urbanization and vector-borne diseases, the like standing water and a lot of other things are so paramount that I think the overall urban form, and then also what that means for how we as humans interact with it, is a really fascinating idea. I have to think about that some more.
Yeah, me too. Thank you.
Yeah, thank you.
It's really interesting, Scott, because we had Bob Davis talk with us earlier in the semester, and he talks so
Okay.
much about how the cold weather was such a significant impact. So when you mentioned that in terms of that one graph, it's just like, oh, we're getting something repeated to us, which is just significant. So thank you.
That's funny. I know Bob. Okay, you should have had Bob and not me back to back. We could have been
Tag
Mr. Heat
team?
and Mr. Cold. But no, I mean, it is. I didn't. Cold is just as fascinating. I'm glad to hear you mentioned that Bob had talked because I didn't get to do nearly the justice that it deserves because it's way more complicated than you could talk about for minutes. So I'm glad to hear that he came and gave the talk.
Yes. Okay. Are we good? Anybody else? I really want to thank you for coming today. It was wonderful, remote or otherwise.
Exactly.
Well, thank you.
Yeah.
Yeah, and again, I wish I could have been there. And so thank you all for having me, and hope you have a great rest of your semester.
Yeah.
Thank
Thank you.
you.
You
Thanks for
and a good.
joining us, Scott.
Thank you.
Take care.
Take care.
Thank
Good to
you.
see
Happy
you.
holidays to you.
You too, Tracy. Bye.
Oh, you're welcome. My pleasure. I just stopped the recording and now I'm going to log off.
Okay.
All right. Thank you.